So in this video we'll be discussing questions related to Jacobian, and there are 5 to 6 questions asked on this topic, and let's see them one by one. So the question 1 says that if u is this and v is this, then find this relation. So they have given us u as x plus y divided by 1 minus xy and v as tan inverse x plus tan inverse y, and we are supposed to calculate del of u comma v divided by del of x comma y and it will be equals to del u by del x, del u by del y, del v by del x and del v by del y. So let's just calculate each of the partial derivatives one by one, and then we'll substitute it in here. So let's name it as 1. So if we find del u by del x, so it will be del by del x of u, that is x plus y by 1 minus xy, and we can calculate it by considering y as constant. So that will give me 1 minus xy into 1 minus x plus y into minus of y divided by 1 minus xy square, and this will be equals to 1 minus xy plus x plus y divided by 1 minus xy square. Now let's calculate del u by del y. That will be del by del y of x plus y divided by 1 minus xy, and this thing will be same as 1 minus xy into 1 minus x plus y into minus x divided by 1 minus xy square. So it will be equals to 1 minus xy plus x square. Here it will be plus xy and y square, and this xy balances this, so it will be equals to 1 plus y square by 1 minus xy whole square, and here it will be 1 plus x square plus xy divided by 1 minus xy whole square, and this xy balances this, so it is equals to 1 plus x square divided by 1 minus xy whole square. Now let's just find out partial derivative of v with respect to x. That will be del by del x of v, that is tan inverse x plus tan inverse y, and it will be partial derivative of tan inverse x will be 1 by 1 plus x square, and other term will be 0. Likewise, partial derivative of v with respect to y will be del by del y tan inverse x plus tan inverse y, and this thing will be equals to 1 upon 1 plus y square. Now let's just plug in all these all 4 of these partial derivative in equation 1. So we'll get del of u comma v by del of x comma y, which is basically the Jacobian, and it will be equals to 1 plus y square by 1 minus xy whole square, 1 plus x square by 1 minus xy whole square, and here it will be 1 by 1 plus x square, 1 by 1 plus y square. So if we just find out, so this is basically the required Jacobian, and it further says that are u and v functionally related. So two functions, let's say two functions a x comma y and b x comma y are functionally related or dependent if a Jacobian with respect to them is 0, that is del of a comma b by del of u x comma y turns out to be 0, then we'll say that a and b are functionally related. Otherwise they are not functionally dependent, or otherwise we say them as functionally independent. Otherwise they are functionally independent. So let's just simplify the Jacobian that we get in here. So that will be equals to basically determinant of this term, and that will be 1 plus y square divided by 1 minus xy whole square into 1 by 1 plus y square minus 1 by 1 plus x square into 1 plus x square divided by 1 minus xy square. So if we just simplify it, this term balances this, and here and also we can balance out 1 plus x square term. So we are left with 1 by 1 minus xy square minus 1 by 1 minus xy square, which is 0. So since our Jacobian is 0, so we can say that u and v are functionally related. That completes the second part, and it further says that if they are functionally related, then find the relationship. So we are supposed to set up a relation in between u and v. So let's do that. So it is given to us that u is x plus y by 1 minus xy, and v is equals to tan inverse x plus tan inverse y. So for timing, let us assume that tan inverse x is equals to w and tan inverse y is equals to z. So that this basically gives me x equals to tan w, and from here I get y equals to tan z. So if I just plug in these values of x and y in the u, that will give me u equals to tan w plus tan z divided by 1 minus tan w tan z. And if you observe that, then this is basically formula of tan of w plus z, because tan of a plus b is equals to tan a plus tan b divided by 1 minus tan a tan b, and this is what we got. So this is formula of tan of w plus z. So if you see that our w plus z is basically v, so it is equals to tan of v. From here you can see that w, that is tan inverse x plus tan inverse y, so v is equals to w plus z. So we got a relation u equals to tan v. This is how u and v are related. So let's move on to the next question. So the next question says that we have relation in between x, y, z and u, v and w, and we're supposed to basically find out its Jacobian only. So the relation that are given to us are x plus y plus z is equals to u, y plus z is equals to uv, and z is equals to uv w. So if you simplify it, if you see that they have given us value of z, so using that you can easily calculate value of y, and using y plus z you can calculate value of x. So let's just find out value of x, y and z in terms of uv and w. So my z is basically uvw, then my y will be uv minus z, that is uvw, and it will be equals to uv into 1 minus w. Likewise, I can calculate my x will be u minus y plus z, and this will be equals to u minus y plus z is basically uv. So if I simplify it, I'll get my x as u into 1 minus v. So I got my relation of x, y and z in terms of u, v, w. This is my x, this is my y, and this is my z. Now let's just simplify it. So I'll get so my del x y z with respect to del of u v w will be equals to del x by del u, del x by del v, del x by del w, del y by del u, del y by del v, del y by del w, and this thing will be equals to del z by del u, del z by del v, and del z by del w. So let's just calculate each of these, partial derivatives. We'll write it here only because it won't be, so del x upon del u will be, this is my x, so del x upon del u will be basically 1 minus v, del x upon del v will be minus of u, and del x of del w will be 0 because there is no w in x. Likewise, I can find out del v y by del u, that will be v into 1 minus w, del y by del v will be u into 1 minus w, and del y by del w will be minus of uv. Likewise, del z by del u will be vw, and del z by del v will be uw, and del z by del w will be uv. Now let's just find out its determinant to get the exact value of the Jacobian that they have asked. So for that we need to solve the determinant. So let's expand it with respect to this row. So it will be 1 minus v into u square v into 1 minus w plus u square vw plus u into v square into 1 minus w plus uw v square, and again plus 0 into the minor with respect to it, that will be like whatever that is, this term will basically reduce to 0, so we don't need to calculate it. So let's just simplify the remaining terms. So it will be u square v minus u square vw plus u square vw and plus u v square minus u v square w plus u v square w. So this term balances out this, and likewise here this term balances out this. So we are left with 1 minus v into u square v plus u into uv square. So if you see that, we can take out u square v, like we can pull out u square v from both the terms. So if I do so, I'll be left with 1 minus v plus v, that is basically equals to u square v only. So, and we can also reduce in terms of x. So we got del x, del y, del z divided by del of uv as u square v. Now let's just reduce it back in terms of x, y and z. So if you see that our uv is y plus z, so I can write it as u into uv. So my u is basically x plus y plus z, and uv is y plus z. So this is basically the required Jacobian. So let's move on to this completes basically this question. That's all they have asked in this question. So let's move on to the next question. So in the next question they have asked that using the Jacobian method, show that f dash x will be 1 by 1 plus x square and f of 0 will be 0. Like if this holds, then we are supposed to show this relation. Okay, so the given thing is, so it is given to us that for a function f dash x is basically equals to 1 by 1 plus x square, and further it says that f of 0 is 0, and we are supposed to show that is our claim is f of x plus f of y is equals to f of x plus y divided by 1 minus xy. Now if to show this, let us assume that our u is equals to f of x plus f of y and v is equals to x plus y divided by 1 minus xy. Now if somehow I can show that the Jacobian of uv with respect to xy is 0, then I can conclude that these are like basically u and v are functionally related, and then I can find out a relation like how u and v are related. So let's proceed in this way. So if I calculate del of u comma v with respect to del of x comma y, so it will be del u by del x, del u by del y, del v by del x, and del v by del y. So if I just simplify it, so del u, let's check what will be del u by del x. It will be del by del x of fx plus fy, and if I calculate it, I'll get f dash x, and we know from the question that f dash x is basically 1 by 1 plus x square. Likewise, if I calculate del u by del y, that will be del by del y into fx plus fy, and it will be equals to f dash y, that is 1 by 1 plus y square. So we got del u by del x and del u by del y. Let's find out what will be partial derivative of v with respect to x and y. So partial derivative of v with respect to x will be del by del x of x plus y divided by 1 minus xy, and it will be 1 minus xy into 1 minus x plus y into minus y divided by 1 minus xy square, and this turns out to be 1 minus xy plus xy plus y square divided by 1 minus xy square, and these two terms we can balance out, so we'll be left with 1 plus y square divided by 1 minus xy square. Likewise, we can calculate partial derivative of v with respect to y. That will be d by dy of 1 plus xy minus 1 minus xy, that is 1 minus xy into 1 minus x plus y into minus x divided by 1 minus xy square, and if you simplify it, you will get 1 minus xy plus x square plus xy divided by 1 minus xy square. So this xy balances out this one, so we are left with 1 plus x square divided by 1 minus xy square. Now if you'll calculate del u comma v by del x comma y, so it will be f dash x, that is basically 1 by 1 plus x square, f dash y, that is 1 plus y square. Likewise, del v by del x is 1 plus y square divided by 1 minus xy square, and here it is 1 plus x square divided by 1 minus xy square. Now if I just solve it, I'll get basically 1 by 1 minus xy square into 1 plus x square into 1 by 1 plus x square minus 1 by 1 minus xy square into 1 plus y square into 1 by 1 plus y square. So this term balances out this, and likewise this balances out this, so we are left with our Jacobian basically 0. So this is 0, so we can say that u and v are functionally related. So if u and v are functionally related, then there exists some function phi such that u is equals to phi of p, right? Now let's just plug in values of u and v, so that will basically give us fx plus fy is equals to phi of x plus y divided by 1 minus xy. Now if you see that, if I put like from here, there are two ways to proceed. So first, let us assume that like if my y is equals to 0, so this will be basically f of x plus f of 0 is equals to phi of x plus 0 divided by 1 minus 0. So from here, if you know that in the question they have given us that f of 0 is basically 0, so I'll use this relation here. So this, since this term is 0, so it will be f of x equals to phi of x. So from here I can say that phi of x plus y divided by 1 minus xy will be equals to f of x plus y divided by 1 minus xy, because here x is variable and I can put any variable here. So I'm just substituting value of v here. So this basically gives me the required relation, because phi of x plus y herein is equals to f of x plus y divided by 1 minus xy, and I can just plug in this value in this equation to get the desired result. So let's move on to the next question. So the next question says that show that the functions u, v and w are dependent and find the relation between them. So basically we're supposed to show that u, that is x plus y plus z, v, that is xy plus yz plus zx, and w, that is x cube plus y cube plus z cube minus 3xyz. So we are supposed to show that u, v and w are dependent, or it is same thing as saying are functionally related. So to prove that, we are supposed to find out its Jacobian, that will be del u comma v comma w with respect to del of x, y, z, and it will be del u by del x, del u by del y, del u by del z, and here it will be del v by del x, del v by del y, and del v by del z, and del w by del x, del w by del y, and del w by del z. So let's just find out what it will be. So if we just calculate del u by del x, it will be 1 only. Likewise del u by del y will be 1, and del u by del z will also be 1. And del v by del x will be, if you take partial derivative of v with respect to x, it will be y plus z. Likewise, if you take its partial derivative with respect to y, it will be x plus z, and if you take it with respect to z, it will be y plus x. Now let's take partial derivative of w with respect to x, that will be del w by del x will be basically 3x square minus 3yz, 3x square minus 3yz, and partial derivative of w with respect to y will be 3y square minus 3xz, 3y square minus 3xz, and partial derivative of w with respect to z will be 3z square minus 3xy. Now let's just simplify this determinant thing and see what we get. What I can do is I can use certain elementary column operations to reduce it. So let's do that. Let's use this C2 as C2 minus C1 and C3 as C3 minus C1. So it will be 1 y plus z, 3x square minus 3yz, and here it will be 0, x minus y, and here it will be 3 into y square minus x square plus plus 3z into y minus x. Likewise, this will be 0 into x minus z, and here it will be 3 into z square minus x square plus 3z into plus 3y into z minus x. So if we just simplify it further, so it will be equals to 1 y plus z, 3 into x square minus yz, 0 x minus y, and from these two terms you can pull out x minus y, basically 3y minus x. So you will be left with y plus x plus z. Likewise here 0 x minus z, and if you pull out 3z minus x, you will be left with z plus x plus y. Now if you simplify this determinant, so you will get, you can expand it with respect to this row, that is row r1. So you will get x minus y into z minus x, 3 times x plus y plus z, minus 3 into x minus z into y minus x into x plus y plus z. Now you can pull out basically 3x minus y into x plus y plus z from there. So you will be left with z minus x, and this got out, and x minus y. So it will be plus of x minus z. So this term balances out this, and this z balances out this. So it is 0. Basically this term into this will be 0. So the Jacobian turned out to be 0. So we can say that u, v and w are functionally related. Now we are supposed to find the relation that is there. So my u is basically x plus y plus z. My v is xy plus yz plus zx, and w is x cube plus y cube plus z cube minus 3xyz. Now if you know that, like we read a relation in high school, that is x cube plus y cube plus z cube minus 3xyz is equals to x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. Now I can write it as, like on the left hand side, if you see that it is basically w, so I can write w as, and this term is u into x square plus y square plus z square minus so I can add basically 2 times of xy plus yz plus zx, and to balance it out I need to subtract that as well. So it will become 3 times of xy plus yz plus zx, because we have this term here as well. So it will be equals to, w is basically equals to u into, now we can club in these two terms to form x plus y plus z whole square minus 3 times xy plus yz plus zx. Now we know value of this is u and this is v. So from here we'll get our w as u into u square minus 3v. That basically gives us w as u cube minus 3uv. So this is basically the relation in between uv and w. So let's move on to the next question. So the next question says that they have given us a u in terms of x and y, and v again in terms of x and y, and we're supposed to find the Jacobian. And further it asks us to show that u and v are independent unless this relation holds. Like if this relation holds, then they are dependent, otherwise they are independent. So first let us find out the Jacobian, then only we'll be able to comment upon its dependence or independence. So let's find out Jacobian, that is del u comma v with respect to x comma y. So it will be del u by del x and del u by del y del v by del x and del v by del y. So if you solve it, you'll get, basically our u is x comma y, so del u by del x will be del by del x of ax square plus 2hxy plus by square. So this basically gives us 2ax plus 2hy. Likewise, del by del y of u will be del by del y into ax square plus 2hxy plus by square, and it will be equals to 2hx plus 2by. Likewise, you can solve it for del v by del x, that will be equals to del by del x into v, and our v is capital Ax square plus 2 capital Hxy plus capital By square. So if you solve it, you'll get 2 capital Ax plus 2 capital Hy, and del v by del y will be del by del y of ax square plus 2hxy plus by square, and it will be equals to 2hx plus 2by. So now let's just take determinant of the Jacobian thing to see what we get. So the Jacobian will be 2ax plus 2hy, 2hx plus 2by, and here it will be 2ax plus 2hy and 2 capital H, 2hx plus 2by. So if we simplify it, we'll get this as equals to 2ax plus 2hy into 2 capital Hx plus 2by minus 2ax plus 2hy into 2hx plus 2by. Now from both these terms, I can take out 4 as common. So I'll be left with ax plus hy into hx plus by minus ax plus capital Hy and small hx plus small by. So if you just multiply these, so you'll get a capital Hx square plus small h capital Hxy plus a b xy plus hby square and minus capital A h x square plus capital H small h xy plus capital A b xy plus capital H small b y square. So let's just club in coefficients of like x square, y square and xy. So it will be 4 times a capital H minus capital A small h x square plus h capital B minus capital H small b y square. And if you see that small h capital H xy, this term balances out this because we have negative sign outside the bracket, and we are left with a capital B minus capital A small b xy. Now this is the Jacobian that we get. So like we are further supposed to show that these are independent unless this relation holds. So for them, like they are dependent if our Jacobian is not equals to 0. Like they are independent if this holds. Independent in this case. Now let's see like when will they be dependent. So for u comma v to be dependent, Jacobian must be equals to 0 for all x comma y. So for time being, let us assume that our x is equals to y. Like they must hold for all xy, so we can basically this must be, Jacobian must be equals to 0 for all xy, no matter what xy we take. So using that, for that to hold, like for all xy, this term must be equals to 0, this must be equals to 0, and this must be equals to 0. So let's just equate them with 0 independently and see what we get. So if I do so, HB minus capital H small b equals to 0 and A capital B minus capital A small b equals to 0. Now I can write it as capital H by small h equals to capital A by small a. Likewise, I can write it here as capital B by small b equals to capital H by small h. And from this term, I can write it as capital A by small a is equals to capital B by small b. And using these three relations, I can say that capital H by small h is equals to capital A by small a is equals to capital B by small b. Now let's see what relation we are supposed to. So we are supposed to prove its inverse. So if this holds, then this must also hold. H by capital H equals to A by capital A equals to B by capital B. So this is the relation that we were supposed to prove. So let's move on to the next question. So the next question says that show that the functions u, v and w are not independent of one another. That is, we are basically supposed to show that they are functionally related or functionally dependent. So our u is basically x square plus y square plus z square, v is x plus y plus z, and w is yz plus zx plus xy. So if I just calculate its Jacobian, that will be del of u comma v comma w with respect to x comma y comma z, and it will be equals to del u by del x, del u by del y, and del u by del z, del v by del x, del v by del y, del v by del z, and here we'll get del w by del x, del w by del y, and del w by del z. So let's just solve it for these values. So it will be 2x, 2y, 2z, and del v by del, it will be 1, 1 and 1 here, and del w by del x will be y plus z. Likewise, del w by del y will be z plus x, and del w by del z will be y plus x. So let's use certain elementary column operations to simplify it a bit, or you can expand it from here as well, but let's just simplify our calculation by using relation elementary operation c2 as c2 minus c1 and c3 as c3 minus c1. So this basically will give us 2x 1y plus z. Here will be 2 of y minus x, 0, and x minus y, and here we'll get 2 times z minus x, 0, and x minus z. Now if I expand it with respect to this column, this row, basically row 2, expanding with respect to row 2, you can expand it with respect to any row, but this will give this. If I expand it with row 2, then it will make my calculation easy because there are 2 zeros in this. So if I expand it, so it will be 2 times y minus x into x minus z minus 2 times z minus x into x minus y. So if I take common as, I can write it as 2 times y minus x into x minus z minus 2 times, this will be x minus z into minus 1, so it will be minus of this term, and here also I can write it as minus of y minus x. So it is same thing as writing 2 times y minus x into x minus z, and it will be minus 2 times y minus x into x minus z, and this turns out to be equals to 0 because these two terms are same. So our Jacobian is 0. So we can say that u, v and w are functionally related. Now let's see what our u, v and w are. U is this. Okay, my u is basically x square plus y square plus z square. V is x plus y plus z, and w is xy plus yz plus zx. So if you know that x plus y plus z whole square is equals to x square plus y square plus z square plus 2 times xy plus yz plus zx. Now x plus y plus z is basically v, so it will be v square equals to, this term is u plus 2 times this term is w. So I got my v square is equals to u plus 2w. So this is basically the relation in between u, v and w. So that's all for this part. There were only 6 questions asked on this topic and we have discussed them. So we'll move on to basically integral calculus from now on, because this completes the differential calculus part of the calculus. So from in the next video we'll basically start with integral calculus. So thank you for watching the video, and if you like it, please like, share and subscribe the channel. Thank you.